Yeah.
Yes, for any rectangular solid. So for example, something like this, right? Like a matchbox, for example. In order to find the volume of this, we need the area of the base times the height. Or it can be the area of the base times the height. It doesn't matter. Or the area of the base times the height. So the area here, because it's a square, it's x times x. And the height is also x. So that's why this is x squared times x. But in general, it's area of the base times the height. Is that okay? Do we have other questions for me? Anything else that you would like to address? Which one?
I'm share my screen. I have something coming up.
Yes, you can. You can. You have. You can share your screen. Anyone can. Which one, Sierra? Okay, perfect. Okay. Find the dimensions of the open rectangular box of maximum volume that can be made from a sheet of cardboard 25 inches by 14. Very good. So we have 25 by 14. And by cutting, yes, congruent means equal squares from the corners and folding up the sides. Very good. And find the volume. Excellent. So find max volume. Perfect. Awesome. You can stop sharing now. That's perfect. Okay. So imagine that this is a 25 by 14. It's not, but just imagine that this is a piece of cardboard and I have 25 inches by 14. So I'm going to remove squares, equal squares, congruent squares from each corner. And they're all the same. And then I will fold up each side. And imagine that I got a box. So this is the box. Okay, so from our figure here, imagine that I remove these corners like I just did. And these corners are all x because they say they're all congruent. So, I mean, this is x, this is x, this is x, this is x, and so on and so forth. So, can anyone tell us when we fold this, what is the height of the box?
X.
Exactly x. Thank you so much. So then, the box now looks like this. So this height is x, this is x. So we have to identify the length, which is this, and we have to identify now the width, which is this. Because obviously our target is the volume. So I have to find the volume of this box. But I can't find the volume before I find the length and the width. So I know it's the area of the base times the height, which is x, but I need to determine L and W to determine the area of the base. So remember, this was 25. I will remove it from here because it's confusing. So the whole thing was 25. But if I cut, so this whole thing was 25. But I cut an x from here and an x from here. So how much is this piece? Just this piece now. So this was 25. So
is it 25 minus 2?
That's it. So this is indeed 25 minus 2x. So this length is 25 minus 2x. So then the volume is 25 minus 2x for the length times, let's see what is the width. What will be the width? So I had here 14, but I removed an x and I removed an x. And now how much is the width? It was
14 minus 2x.
14 minus 2x. And then times x. So this is the volume of the box. Good. So next step, I need to multiply all these. I always recommend multiply these two first, and then at the end distribute x. So then the volume is indeed a function of x. Now I can for sure write that. It's a function of x. And now I need to multiply 25 by 14 minus 25 times negative 2x. 2x times 14, but negative, right? Negative 28x. And negative 2x times negative 2x, which is positive 4x squared. At the end, I will distribute x in the correct order. So 4x to the third. Now this is negative 78, negative 78x squared. And I'm looking for my calculator because I'm lazy. So what is 25 times 14? 350. So plus 350x. So here's what we did one more time. This times this, 78x times x with negative, and these two times x. Good. Finally, I have the function. Remember, I'm after maximum. What do I do next after I find the function in order to find its maximum? What is my next step? Chapter 3.
Study the sign.
No, I don't have the function for which to study the sign yet. I need that function for which I study the sign. I never study the sign of the function, but I study the sign of the derivative. So I need the derivative now. So 12x squared minus 156x plus 350. Good. I have the derivative. Step number 1. Step number 2. What do I do with the derivative? Before I study its sign, not yet. What do I need to find next?
You set it equal to 0. And
yes, we find critical numbers. Very good. So v prime of x equals 0, or v prime of x is undefined. Well, no, because it's a polynomial. So let's set it equal to 0. 12x squared minus 156x plus 350 equals 0. Yes, it's quadratic, but why not? I'm going to do this. I'm going to go to apps. I'm going to choose 9. I'm going to choose polynomial root finder. I'm going to choose grade degree 2 or order. I am going to enter 12. I'm going to enter negative 156. I'm going to enter 350. And I want solutions quickly. 2.88. So x equals 2.88 inches, and x equals 10.12 inches. So if this is 14, can this be 10 and this be 10 for x being 10? Can this be 10 and this be 10, but this whole thing be 14?
No.
No. Now, I don't know if this gives a maximum or a minimum. I have no idea. Well, I do, but you know what I mean. I have no idea. Even if I do, I have to show that x equals 2.88 inches gives a maximum. Okay, how do we do that?
Is it a maximum because it's positive?
I was just looking at that, and I was thinking to see that that's why we always do this, to make sure that there is no error. We were asked, I don't have the problem, but I'm assuming I read it correctly, right? They wanted us to find the maximum volume. So this was indeed 25 minus 2x, and this was 14 minus 2x. That's correct. And then x. I don't think I made any error anywhere. So this is 12x squared minus, yes, okay, that was okay. Because the positive will give us a minimum. So can you read the problem for us one more time just to make sure? See, at 0, so in between solutions is the opposite. Oh yeah, that's correct. No, you don't have to read it again. You don't have to read it. I see what happens. Because there is a 10, there is a 2 and 10, and this will be negative. Yes. So everything is fine. So when x is 0, see here, 0, 0, 0, positive. But if you plug in 5, and I can show you, because it's between solutions. So 2 and 10 are the solutions. And the function is negative between 2 and 10. So I can show you. I'll share my screen. And if we put the function in, you will see 12x squared. 12x squared. And then minus 156x. So I don't know how many decimal digits they want. I only wrote 2. Do they want more than 2 decimal digits? Do they want the volume also? So this is the derivative. So when we plug in 0, you will see what happens. When we plug in 2, it's still positive. When we plug in 3, actually, when we plug in 3, it should be negative. When we plug in 12, it should be positive again because we go over 10. Okay, so everything is perfect. So it's exactly what we expected it to be. Now in y equals, in case they're asking us to find the volume, then I have to plug in the volume. 4x cubed, and then minus 78 x squared. That was the volume, plus 350x. Okay, so then I have to plug in this 2.88. And that is the maximum, 456. So this is a maximum, and the volume is 456.59 cubic inches. So I don't remember, I'm so sorry, who asked about this. I was Sierra, maybe. Does it ask 2 decimal digits, or you need more than 2 decimal digits?
Wanted 1.
Wanted not, well, if it wants 1, be very careful. So this will be 2.9 inches, and now I have to.
It wanted 2. I'm sorry, I read it wrong.
Okay, that's okay. So if it wants 2, then you have to plug in 2.88, and here 456.59 if they want the actual volume.
Thank you.
Everything okay? Is it clear now?
Better.
Okay, perfect. Okay, is there anything else anyone needs help with? Anyone? Okay, so I would like to review with these problems. Okay, so I don't think we are going to have enough time to do this one. So I'm going to see if we can, if I do, we'll go back to it. But I'd like you to go back to our homework problem. Homework from 3.4, I believe. Okay, so let's try the other ones. Okay, I'm going to share my screen. and go to, where's my book? Okay, go to any page, it doesn't matter, and then I'll type it in unless I'm logged out. I hope I'm not logged out. Please. Okay, I'll do it again. And we want to start with page 205. I didn't mean to cut you off. Does anyone need anything else? Maybe you wanted to say something and I didn't wait long enough. Okay, so in 205 I selected 84. So the population years after 2017, so this is 84 on page 205. So it means t equals 0 means 2017, and we have a function p of t equals 17,250 e to negative 0.0512t. What will the population be in 2024? When will the population first drop below 14,000? And when will the population be, okay. So I'm going to ask different questions here. So that's one. And in part B, I want to ask a different question. So here, obviously, we're going to have to, I'm going to ask you in a minute. But the second question, that's all I want. I want two questions. Find the rate of change. Find the rate of change and then evaluate it for t equals 10 years. That's all I want. So find the population in 2024 and find the rate of change, and then evaluate the rate of change for, if you want, 2024 or 10 years later from 2017. So how do we address the first part?